Alright, so let's talk about the mole concept today. And so we've done our alphabet. We've learned the symbols for the elements. We've done our spelling. We've learned how to read and write words, the names and formulas of compounds. So today we're going to start doing a little arithmetic. We'll be counting atoms and molecules and ions. So that's the whole idea behind the mole concept. Uh, it's a way of counting atoms, molecules, and ions in groups called moles. Just like a farmer would count eggs by the dozen, we count atoms, molecules, and ions by the mole. So what's a mole? A mole is a group count, just like a dozen. So you know that a dozen items would be 12 items. Well, if we're counting atoms, molecules, and ions, they're so small that we have to use a bigger count. So a 1 mole represents what we would call a 24-digit Avogadro's number, which is a 24-digit number. We don't know all 24 digits exactly. It's an exact number, but we don't know what all those digits are. But the first 8 significant digits are 6, 0, 2, 2, 1, 3, 6, 7. Okay, so the number itself is 6.02 times 10 to the 23rd. For most practical purposes, you only need 3 or 4 sig figs. So you can use 6.022 times 10 to the 23rd or 6.02 times 10 to the 23rd. In terms of words, you can say that it's about 602 billion trillion. Remember, a billion has 9 zeros, a trillion has 12 zeros. So that's 10 to the 21. So 602 times 10 to the 21 is the same thing as 6.02 times 10 to the 23rd. Okay, so that's how big that count is. So keep in mind, when we talk about moles, we're just counting things. So whatever applies for small counts, it will apply for a mole count, pretty much. So here's a quick question just to check if you understand what a mole is. Which has more atoms? A sample that has 1 mole of carbon-12 or a sample that has 1 mole of carbon-13? Clicker question. Okay. Uh, Everyone said B. Okay. Let's see. If I were to ask you which has more flowers, let me just make it different. Which has more people? 1 dozen, uh, 1 dozen kids, or 1 dozen dads? Okay. A carbon-12 is simply lighter, an atom that's lighter than a carbon-13. So if I ask you a dozen kids versus a dozen dads, which has more people? What would be the answer? Same number of people, right? So this is actually a trick question. The correct answer here is the same. All right. The 1 mole of carbon-12 will weigh more. Yeah, it was a trick question. Uh, 1 dozen, 1 mole of carbon-13 will weigh more than 1 mole of carbon-12. But I'm trying to emphasize here that when we're doing moles, we're counting things. So a mole is a count. So a mole of carbon-13 uh, has the same number of atoms as a mole of carbon-12. Okay? You can just make that a bonus clicker question if you want. All right. So how about this one? Um, Relating moles and individual counts. Consider a sample that has 2 moles of CO2. How many molecules are there in that sample? Well, think of it this way. If you have 1 mole, remember you have 6.02 times 10 to the 23rd items, right? So that whatever it is we're counting, it can be atoms, molecules, or ion. If you have 2 moles, so this is the mole count, this is the actual number count, individual count. If you have 2 moles, then you have 2 times 6.02 times 10 to the 23rd. If you have 3 moles, then you have 3 times 6.02 times 10 to the 23rd. That would be the actual count. Just like saying if you have 1 dozen, then you have 12 items, right? If you have 2 dozen, you have 2 times 12 items, or 24. If you have 3 dozen items, then you have 3 times 12, or 36 items. So in other words, if you know the mole count, let's represent that by the small letter n, you multiply that by Avogadro's number. Remember, Avogadro's number is 6.02 times 10 to the 23rd, to 3 significant digits. That will give you the individual atom count or molecule count if you're counting molecules. Okay, so keep in mind, since mole is a count, we have to specify what it is we are counting. So here, when you say 2.00 moles of CO2, that means we're counting carbon dioxide molecules. By the way, this abbreviation right here, MOL, is abbreviation for mole. Okay, it is not to be used to abbreviate anything else. So you cannot use that to abbreviate molecule. So MOL, we only use it as the official abbreviation for mole. So if in this question you're asked, how many molecules are there in a sample that has 2 moles of CO2? So you would say 2.00 mole times Avogadro number, which is 6.02 times 10 to the 23rd molecules per mole. Okay, what kind of molecules? In particular, CO2 molecules. So you can see your units, your mole unit cancels out. Okay, so the answer here is 12.04 times 10 to the 23rd. 2 times 6 is 12 CO2 molecules. Okay, now you can see that this is essentially a conversion type calculation. So if you prefer to do it using what's called the picket fence approach, you can just say 2.00 mole CO2, and then you put down here 1 mole CO2 is 6.02 times 10 to the 23rd molecules. Okay, so mole CO2 cancels out. It's actually preferable to use 4 sig figs here, 6.022, since you have 3 sig figs here. So 6.022 times 10 to the 23rd would be a better number to use there. Okay. But your final answer, how many sig figs should I have in my final answer? I only have 3 sig figs here, so my final answer should just be equal to 1.20 times 10 to the 24 CO2 molecules. Okay. Right. So if you know the mole count, you can figure out the individual count by multiplying it by Avogadro's number. What if you know the actual count? How do you figure out the mole count? And then you just go the other way. You just divide by Avogadro's number instead. Okay, so our formula here is the mole count times Avogadro's number is equal to the actual count. So that's another way of expressing that diagram right there. So if I know my actual count, I know the actual number of atoms, I can change that to a mole count. It's like saying if I have 24 items, I change it to a dozen count, I divide it by 12. This time you divide by Avogadro's number. So you would say then that you have, so if your individual count is 3 times 10 to the 23rd, I want to solve for n here. I can say that n, I'll divide both sides by Avogadro's number. So I can say n is the number, actual number, divided by Avogadro's number. So 3.00 times 10 to the 23rd atoms, magnesium atoms, divided by 6.02 times 10 to the 23rd. And the unit for Avogadro's number would be per molecule of whatever you're counting. So in this case, it's atoms per molecule, per atom, per mole. I'm sorry, atoms per mole. So atoms cancel out, That gives you the answer in moles. So that should be about, what's 3.00 divided by 6.02? 3 divided by 6.02, that should be 0.498. Okay, so this is 0.498 moles. Now, if you prefer, you can think of this as a conversion problem. So you can say, here's another way of doing it. You can say you have 3.00 times 10 to the 23rd atoms, okay, times 1 mole of atoms has 6.02 times 10 to the 23rd atoms. Okay, and so your atoms cancel out. That gives you the number of moles of atoms, which would be the same answer as we had earlier. Okay, so that's what a mole is. It's just a way of counting atoms, molecules, and ions. You count it in groups. Now, what if you want to count atoms that are part of molecules? It's like saying, what if I ask you, there are 10 people, how many fingers are there? What do you do? The formula for a person would be 1 hand, 10 fingers, 2 eyes, you know. So if each person has 10 fingers, I tell you the number of people, what do you do to get the actual number of fingers? Well, whatever the molecule count is, not the people count, you multiply by the number of fingers. So in this case, the subscript tells you how many atoms you have in a molecule. Okay, so molecule count multiplied by the subscript of a particular atom you're interested in will give you the atom count. All right. So here in this example, you have a question: how many oxygen atoms are in 2 moles of CO2? So you say 2.00 moles CO2 times there are 2 moles of oxygen in 1 mole of CO2. Okay, so this 2 right here, that's the subscript, that's the subscript of oxygen in CO2. It's like saying there's 2 eyes per person. So number of people will be multiplied by 2 to get the number of eyes. Okay, so this would be 2.00 times 2 over 1. That gives you 4.00 mole of oxygen. You'll notice moles of CO2 here is going to cancel out. So your final unit would be moles of oxygen. Now, as far as sig figs go, this has 3 sig figs. Okay, these are small counting numbers. 2 and 1 are counting numbers, so those are exact numbers. They have an infinite number of sig figs. So your final answer should only have 3 sig figs. Okay. How many atoms are in 2 moles of CO2? How would we do this? Well, same thing. You just say, okay, 2.00 moles of CO2 times, well, what's the total subscript here? Carbon has a subscript of 1. So you know that there are 3 atoms in 1 molecule, right? So you know that you have 3 moles of atoms in 1 mole of CO2 molecules. So mole CO2 cancels out. So 2.00 times 3 would give you 6.00 moles of atoms. Okay. Okay. Let me stretch this out a little bit. Let me make this problem a little challenging. Let me give you a question here. How many CO2 molecules contain 5 moles of oxygen atoms? Well, again, you go by the fact that the number of CO2 molecules, right? You multiply by the subscript, which is 2 moles of O2 per mole of CO2. would give you the number of moles of oxygen. So you can solve for the moles of oxygen here. So essentially, what do you do? If you have five people, if you have 5 eyes, then you have 2.5 people. You could say 5 dozen people, 5 dozen eyes. Then you know you have 2.5 dozen people, right? So basically, if you divide this by 2, then you get the moles of CO2. So here's a way to do it. You can say divide this by 2. Right? So number of moles of oxygen would be number of moles of CO2. Okay, I'll just move this conversion factor to the other side. Number of moles of oxygen times 1 mole of CO2 for 2 moles of oxygen. See? So now I have number of moles of oxygen is 5.0 moles. Okay, and you can set this up like a picket fence. You can say times 1 mole of CO2 over 2 moles of oxygen. So you can twist this problem around and work backwards instead. So 5 divided by 2, that gives you 2.5 moles of CO2. Right? So it's all about counting. And just have to keep in mind that subscripts in the formula are counting numbers. They tell you how many atoms you have in a molecule. Let's apply that to ionic compounds. Okay, let's count ions in compounds. Same idea. If you're asked for the number of ions in an ionic compound, whatever the formula unit count is, whatever moles of that compound you have, you just multiply by the subscript of the ion to get the actual ion count. So here's the question. How many moles of ammonium sulfate, how many moles of cations are in 3.0 moles of ammonium sulfate? This is where you need to know how to write the formula of the compound. Okay, so this would be a good practice for you to review for your test. Reading and writing formulas. So ammonium sulfate, you have to figure out what that formula is. Okay, so what's the formula of ammonium sulfate? Ammonium is NH4 plus, and sulfate is SO4 with a -2 charge. So what's this formula going to be? The compound is going to have a formula of NH4 parenthesis 2 SO4. One formula unit has 2 cations, 2 ammonium ions, and 1 anion. Okay, so 1 mole of this ammonium sulfate is going to have 2 moles of ammonium ions and 1 mole of sulfate ions. So to solve this problem, you say, I have 3.0, was it 3.00? Oops, what did I just do? Let's go back. So I have 3.0 moles of ammonium sulfate. So I have 3.0 mole of ammonium sulfate times I have 2 moles of cations, and my cations happen to be ammonium, in 1 mole of ammonium sulfate. So moles of ammonium sulfate cancels out. That gives you 3.0 times 2, 6.0 moles of cations. Our cations happen to be ammonium ions. Okay? 2 sig figs for 3.0. That's an exact number. That's an exact number. That will have infinite number of sig figs. So your final answer should have 2 sig figs, 6.0 moles. Okay, so this clicker question now. Let's do a quick review. Which has more atoms? 1 mole of magnesium 24 or 1 mole of magnesium 26 or neither? Correct answer is C. Very good. Which has more molecules? 1 mole SO2, 1 mole of SO3, or neither? Okay, that's fine. Three B's and 10 C's. Okay, so very good. This is like asking which has more vehicles. A dozen, let's see, I can't draw well. A dozen bicycles or a dozen tricycles, right? Same number of vehicles. One just happens to have more wheels. More. So SO3 will have more oxygen atoms than SO2, but since we're counting molecules, we're comparing the molecules, the actual groups, you'll have the same number of molecules. Okay? All right, let's look at a true or false question here. Which of these is false? A mole of atoms contains exactly 6.02 times 10 to the 23rd atoms. B, the exact number of molecules in 1 mole of molecules is equal to Avogadro's number. C, the exact number of ions in 1 mole of ions is equal to Avogadro's number. Or D, none of the above. Okay. Uh, Nobody picked the right answer. This A right here is false. It's not exactly 6.02 times 10 to the 23rd. Remember we said the exact number is a 24-digit number, and this is just a rounded value to 3 significant digits. Okay, if you have a mole, you exactly have an Avogadro's number. 6.02 times 10 to the 23rd is not exactly Avogadro's number. Avogadro's number is the 24-digit number, the exact number. Okay, when you round it, for most purposes, you can round it up to just 3 significant digits. So A here is false. Okay? So anytime you say you have a mole of something, you have an Avogadro number, a mole of Avogadro number of that thing. Okay, but it's not exactly 6.02 times 10 to the 23rd items. It to 3 significant digits. If you round it off to 3 significant digits, it will be 6.02 times 10 to the 23rd. In fact, if you round it up to 4 significant digits, it will be 6.022 times 10 to the 23rd. Okay, how about this one? How many atoms of carbon are in 2.50 moles of carbon? Is it 1.51 times 10 to the 24th, 30, or 4.15 times 10 to the negative 22? I'll give you a little time to work this out. Okay, no problem. Okay. All right. Obviously, it's what? A? Good. Okay. You can tell right away you cannot have a fraction of an atom, so this number is unreasonable. 30 atoms, that's too few. Okay. So you have 2.50 mole of carbon, and 1 mole of carbon is 6.02 times 10 to the 23rd atoms of carbon. So 2.5 times 6.02 times 10 to the 23rd would be a huge number. If you're actually counting, if you have actually specifying the number, actual number, that would have to be a huge number. Okay. All right. How about this one? How many moles of O2 are in a sample containing 3.0 times 10 to the 22 oxygen molecules, O2 molecules? How many moles of molecules are in this many molecules? Is it 2 moles, 1.06 times 10 to the negative 1 mole, or 0.05 mole? Did I start? Did I record? Yeah, I did. Okay. Okay, popular answer is C. That's good. So you have 3.0 times 10 to the 22 molecules of O2 times 1 mole. You're looking for moles of O2. So 1 mole of O2 molecules has 6.02 times 10 to the 23rd molecules of O2. So molecules of O2 cancel out, you get moles of O2 molecules. So that's going to be 0.05. Okay, how about this one? How many atoms are in 1.50 moles of CO2? Is it 1.5, 0.3, 3, or 0.75? How many atoms of oxygen are in 1.50 moles of carbon dioxide? So we have an answer. C. C. Okay, good. 1.5 times 2. All right, so 1.5 times 2 gives you 3. Okay, if you want to work it out, if you want to show your work, then you can say 1.50 mole CO2 times 2 moles of oxygen in 1 mole of CO2. So moles of CO2 cancels out. Okay, so that's 3.00. How about this one? Which has more atoms? 3.0 moles SO2 or 2.0 moles SO3 or neither? More atoms, okay? Okay, let's see. 3.0 mole of SO2 times, that's SO2. So that's 3 atoms, right? In one SO2. So 3 moles of atoms in 1 mole of SO2. So 3 times 3, that gives you 9 moles of atoms. So this has 9 moles of atoms. Okay, and then let's look at the second one. 2.0 mole of SO3. Okay, SO3 is S10O3, so that's 4. So you have 4 moles of atoms in 1 mole of SO3. Okay, so 2.0 times 4, this gives me 8 moles of atoms. Oops, I'm sorry. This second one has 8 moles of atoms. So 9, 8, so it can't be C. Okay, so which one has more moles of atoms? Correct answer is A. Alright. So there's 8 moles of atoms in 3, it's 9 moles of atoms in 3 moles of SO2. How about this one? It's the same question, huh? Oh no, this one's different. This is only asking for oxygen atoms. Which has more oxygen atoms? Is it A, B, or C? 3 moles SO2, 2 moles SO3, or neither? Very good. Okay, so you say 3 moles SO2 times 2 moles of O for 1 mole of SO2. That gives you 6. Okay, so this has 6 moles of O. And then the second one, you have 2.0 mole of SO3 times 3 moles of oxygen for 1 mole of SO3. So 2 times 3, this also has 6 moles. So the correct answer is they have the same number of atoms. How about this one? How many cations are in 2 moles of Na3PO4? So you have to kind of go back to interpreting that in terms of what part of that are cations, how many cations do you have in 1 formula unit of that. So how would you solve it? What would be the answer to this question? 2 moles of Na3PO4. How many cations are there? What's the answer? I can't hear. B? Very good. That's good. 2.00 mole of Na3PO4. And the cation here is sodium. So you have 3 of those, right? And the phosphate is the negative ion, PO4 with the negative 3 charge. So sodium is the cation. So you say 3 moles of sodium ions in 1 mole of Na3PO4. Good. So that gives you 6 moles of cations. And finally, here's a challenge. You have 2 moles of nitrate. How many moles of nitrate ions in a mixture that has 2 moles of calcium nitrate and 1.5 moles of aluminum nitrate? So you kind of have to know what the formulas are. So what's the formula for calcium nitrate? CaNO3 2. Okay. And aluminum nitrate is, aluminum is plus 3, and if you remember, nitrate is NO3 with a negative 1. AlNO3 3. So in this case, what you'll need to do is count the nitrates that came from calcium nitrate and count the nitrates that come from aluminum nitrate. So you're going to say 2.00 moles of calcium nitrate times 2 moles of nitrate in 1 mole of calcium nitrate. So that gives you 4. 2.00 times 2 is 4. And then you count the nitrates that come from the aluminum nitrate. You have 1.5 moles of aluminum nitrate up here. So you say 1.50 moles of aluminum nitrate times 3 moles of aluminum, 3 moles of nitrate for 1 mole of aluminum nitrate. So moles of aluminum nitrate cancels out. So let's see, 2 times 2, that's 4. 1.5 times 3, that's 4.5. So that's a total of, so 4.00 plus 4.50, that gives you a total of 8.50 moles of nitrate ions. Okay. So 4 moles comes from calcium nitrate and 4.5 moles comes from aluminum nitrate. And so that is the mole concept. It's all about counting. Okay, so I'm going to go ahead and stop this recording.